We have converted the production at the customers in many applications to the HERA technology. We could measure it. It was that we have reduced the cycle time between 20 and 30%. It came mostly because you don't need to spray as long anymore to cool down externally the mold. And this is what goes directly into the cycle time. You can save this. On the other hand, we could save 99% of the dilution water, what was needed before to dilute the release agent before application. Scrap rate was also improved by between 10 and 15%. It was a little bit depending on the kind of parts which were manufactured. So you see there are saving possibilities by using this technology properly, mainly in the 2-digit area.
Hello, welcome to the Gold Casting Podcast. Today, the sun is shining, and we also have some energy in the room today, as we have Darko Tomazic from Chem-Trend with us. And the reason why we are so super excited is that Chem-Trend is, I would say, leading the way of reducing emissions and making sustainable castings practically by working on the floor among many foundries. I know that a lot of people already know Darko Tomazic. Anyhow, for those who may not know you, Darko Tomazic, could you please introduce yourself a little bit?
Yes, of course. Hello, Stefan. Hello, Fabian. Thank you very much for this opportunity and invitation to have our talk today. Yeah, who I am? My name is Darko Tomazic. I'm at Chem-Trend since 1997. Over the years, I have held various roles in our company. Today, I am the key account manager in the high-pressure die casting industry in Europe. I'm also responsible for the casting activities in Scandinavian and UK territory as a sales manager. Over these 26 years at Chem-Trend, I have supported our die casting customers on many casting topics and projects and have supported them through numerous changes in process technology.
So, the reason why people call you is that they have a problem with the casting, the process. And end of the day, they need to do something to get the parts out of the machine and make money.
Yeah, this is true. There is no client, no customer, no foundry who can claim that they have no issues or challenges. The reason why customers are calling us is that they know Chem-Trend, they know we are reliable. We have people in the field who can support them on site and solve commonly with the customers the topics which need to be addressed.
I think that's so super important. It's like Mr. Per Jansson at Complex says, everybody can buy a die casting machine, but once you have it, you need help from everybody to keep it running.
That's true. To have a car doesn't mean that you will become a good car driver.
No.
That's a good one.
No, that's especially right. And especially problem solving. If you have an issue with your casting or your casting isn't making money, usually the first thing isn't that everybody looks at the release agent. But it plays such an important role that's so underestimated.
This is true, Fabian. If a problem occurs, the release agent is the number one, which is addressed. If you take a deeper look, it is not essentially the release agent itself. It's very often a combination of many factors which get together and create some challenges. We know about this. We are faced with such kind of calls on a daily routine. And by experience over all the years with our valuable colleagues out in the field, we know already where to start to put the fingers in, to make an assessment and look what is really the root cause for issues.
What kind of factors are you referring to here? To be a little bit techy. I know that we're not supposed to speak about technology here, but I cannot help myself. What kind of factors do you need to take into consideration for finding the solution?
Normally, we start with a process assessment. Is the temperature in the right range? Is the dilution ratio properly? What about maybe some microbiological contamination of the release agent? The release agent is an emulsion, what means it is attackable by microorganisms. And if you don't have any hygienic concept in the foundry, especially in summer months, in warm summer months, then it's very natural that you will be faced with some issues with those little animals. And
brewing beer here in the
this is the positive side of bacteria, but in the foundry you don't want to have beer. You need a release agent which is demolding your cast parts. Then additionally, the spray pattern needs to be checked. If you apply the release agent really at the area where the release agent is needed, sometimes you have hot spots and they are not covered properly. Or in other areas, you spray simply too much and then you undercool the mold surface. And with the undercooling, you have not the capability to build a film formation. And you need to keep in mind that, for instance, the release agents, they are water-based. And as long as you don't evaporate the water, you have not the capability to form a film on the mold surface.
You have something you call HERA, right?
Yeah, this is correct, Stefan.
What is that?
Yeah, it is a nice acronym for high efficiency release agent. But because the name is so bulky, we gave it a more nice name called HERA. HERA is technology. It was developed in conjunction with a project with the University of Braunschweig in the years 2009 till 2012. That time already to reduce CO2 emissions and energy consumption. And it is a release agent concentrate which is applied on the surface. So you don't dilute it with water anymore. And the benefit of this kind of technology is by missing the thermal shocks on the die surface, you can prolong the die age.
So you're the toolmaker's worst enemy then?
I hope not. I hope I'm not on some wanted list at the toolmakers. Up to now, I got no threat from them.
Oh, great.
Yeah, I think also that they're quite happy with the technology, as the manufacturing is more complex for a microspraying tool. As, please correct me if my numbers are wrong, but around 25 to 40% of the cooling is taken away by the water when you spray conventionally. When you do microspraying, that heat has to go through the tool out, otherwise you overheat anyway.
That is totally correct, Fabian. The basic requirement for an HERA or microspray technology, as it is called as well, is that you need to have the temperature control of the die casting mold internally. Means you need to set up your cooling channels and cascades in a way that you really balance the energy which is coming in by the aluminum, by the molten alloy, with the internal cooling. And the release agent has only the function to build a release film and to demold the part itself without bringing any disadvantages like higher microporosity or other things into the cast part.
But if I say like this then, Darko, 15, 20 years, 25 years ago, when I started in this industry, spraying was, emulsion, water, splash it on the tool surfaces because the parts were stupidly easy. Of course, the foundries had challenges back then as well, but they were more easy. Today's parts, we're speaking about carbon dioxide compressors, we speak about Rio casting, for example. We have the gigacastings, big structures, thin-walled, high speeds, other alloys. Do you agree that the parts of today are so much more complicated that what was overseen over the shoulder 15, 20 years ago now is something you have to take into consideration, like spray system in a total different level?
This is right, Stefan. The complexity of the parts did change because with the increasing closing force of the die casting machine, you combine more and more parts to one. This leads automatically to a higher complexity grade, and therefore we need to rethink the processes. We can't apply a lot of water or diluted release agent on the surface anymore by several reasons. If it's environmental reason, if it's a technological reason, we need new processes for all these demanding complex parts. Mm-hmm. And we should not forget the part itself is not only the demanding point in a casting process. We need to consider the subsequent processes as well. Nowadays, the parts, they are e-coated, they are adhesive bonded, and all these operations, they are quite sensitive on what is the quality of the parts. Mm-hmm. And if you use the wrong release agent or over-apply process chemicals, then you can be sure that once you have run the entire added value chain for this kind of part, you might get at the end of this chain the big surprise that you put in a lot of investment and time. You made this part, and then it's scrap because you have maybe weak bonding, or you have not a proper coating layer of the e-coating on the surface. Therefore, it's so important that you really consider what you bring in at the beginning of the process will definitely influence the final result of the cast part itself.
But are you involved early in the project, or are people calling you and your team when it's too late, when the problem is on the table?
Meanwhile, the industry has learned. So it is today easier to start such kind of projects from the beginning one. So there is an involvement of us as Chem-Trend, for instance, as the process chemical supplier, but also other companies who are supplying the plunger lubrication, or they are doing the spray cassettes. So because the processes are so complex, we recommend and also push the customers to involve all the involved parties of suppliers in the beginning of such a project. And then it's much easier to run it and to get targeted to the success which is requested.
Teaming up is the key word. Yeah.
Definitely. By this complexity in the process, you are not capable to give the right solution just by a standalone supplier.
Yeah, especially as we had it, when you need the proper cooling in the tool, the right spray system, and then the release agent is just one part of that system. If one gear is missing, the whole system doesn't work. And if it's not implemented, there is no chance just to drill an additional cooling channel while the tool is on the machine. That's impossible. This has to be done way earlier.
Totally correct.
I can actually give an example, making your life a little bit easier now, Darko. We had a problem. We were doing some reo-casted compressor housings for a client, and we had super problems. And then we actually did this. We teamed up, with our old machines from the 90s. And you were standing in our foundry for what, 2 days?
Yeah.
And
several times for a couple of days. You are right, Stefan.
Yeah, and our guys have been scratching their heads for quite long. We have produced piles of bad parts, and then Mr. Darko walks in and says, "Well, guys, the metal is on the same spot for a very long time in your process. So here, take one manifold and spray something thicker on that point. Especially where the in-gate meets the part. Sorry for being taken out. And then you take the rest with a release agent, and ba-bam, it worked."
Yeah,
that's local presence for you. It's super local. We're speaking about Skillingaryd, Fabriksgatan 49. It's just a dot on the world map of casting. But anyway, it was important for us. We made it.
Stefan, fortunately, I'm not just since 2 years at Chem-Trend, but since many more years. And this is what makes me also happy, the experience I could gain in the industry all over the years. And thank you to all our clients who made me more clever than a couple of years ago. It's really a great and good feeling to participate from this kind of knowledge, which can be also given then to new projects, to new clients. And we don't need to reinvent the wheel from scratch always. We can step in at a much higher level than it was done in the past when you started always at zero.
But I want to revert back to one thing. You said that there's no foundry that doesn't have any ways that you can actually work with. I mean, give and take. If you would walk into a foundry that's not super optimized, but I mean average, what are you doing there? I mean, are we making 2%, 4%, 5% on the final row on the P&L or the profit margin, or how would you regard how much could someone actually gain from calling the local Chem-Trend guy?
The task can be very different. So sometimes it's pure quality tasks, which lead, of course, in the end to profitability. Sometimes it's really to lower the cost, because we were all faced with increasing costs over the last 2-3 years, and therefore it is really necessary to address these topics. And if we have to solve technical issues, we make the technical assessments, which we discuss internally later on and provide then appropriate solutions. If they are commercial requests, then we need to think about what can be done. We have developed now, since the last 2 years, a lot of new products, because we know the pain of our customers, and we all together are dependent to be successful. And with these new products, we can really help the customers also to address their commercial needs.
But you have the HERA that we discussed a little bit earlier, but then you have something you call handprint. What is that?
The handprint means we do not consider only the so-called footprint, means low CO2 values, low energy consumption. But with the handprint, we try to leave as best as possible savings at the customer. And this is called the handprint. Handprint means lower scrap rates. Handprint means lower wastewater, which remains. This is what we call as a handprint. So something what the customer can see and also feel after we have improved his processes. This is our handprint.
Oh, that's perfect. Do you have some case studies to showcase that, where you have actual numbers behind it?
Yeah, with actual numbers, gentlemen, it's very difficult, because all the projects are combined today with very tight NDAs, but I can give you a general overview about what we have done at a customer.
That sounds good.
So we had a task years ago, 2-3 years ago, that a known foundry has requested us for developing and improving their processes. We have made this assessment, and what we are doing normally at the customers with some infrared images, with controlling the consumption of release agents, scrap rates, etc. And once we have everything together, we reviewed it internally and thought about what could be the solution for the customer. Fortunately, the processes he did run were capable to be covered by HERA technology. We presented the customer then our project, how we could help him. He accepted it, and then we have started with the trials. Our people were on site together with the customer employees that start to implement the HERA technology. We involved also the spray equipment supplier, because we did need to change the spray equipment, the spray cassette, to be able to spray minimum. And after the start, everything, because it was well prepared before, did run smooth. We did start with a kick-off trial. We did prolong it then for a long-term trial. And finally, we have converted the production at the customers in many applications to the HERA technology. So, of course, you would like to have now some figures, which is a little bit hard to give you. At least I can say what is known to us, because we could measure it. It was that we have reduced the cycle time between 20 and 30%. It came mostly because you don't need to spray as long anymore to cool down externally the mold. And this is what goes directly into the cycle time, you can save this. On the other hand, we could save 99% of the dilution water, what was needed before to dilute the release agent before application. And subsequently, if you don't spray a lot of water on the mold, you don't have any wastewater later on. So the wastewater was removed 100%. Scrap rate was also improved by between 10 and 15%. It was a little bit depending on the kind of parts which were manufactured. So you see there are saving possibilities by using this technology properly, mainly in the 2-digit area.
That's amazing.
I hope this helps you, this kind of very surfacingly figures.
But jumping around with the figures, I was in Ireland when this podcast was actually born, and it was at the seminar, the guys from Volin showed an example where I think it was 35% of the energy consumption in the casting, not melting aluminum now, was actually from bad spraying, pouring water over the tools. So if you reduce the fresh water with 99%, I kind of suspect that you also save some energy somewhere, because water is energy, just in another form, shape.
Yeah, you wash down your tool, cool the surface like crazy, and then the heating system has to be up there and heat it up again, and then you have to cool it again, and then you spray it and you heat it up. So there's a lot of high intensity heating behind it if you wash your tool down. And we don't talk about the lifetime, because if you wash your tools down, please correct me, but at least after 30,000 shots, you will see the first heat cracks.
Yeah. So, Fabian, you have summarized it very well. There are really big savings in energy if you consider electricity, because like Fabian said, you heat up the mold, then you cool down it with the water, and then you need to heat up it again to get the right casting property. All the things can be removed, and 5%, I think this is a little bit low, what the colleagues from Volin told. We have the experience, meanwhile, you can do it between 20 and 30% if you don't have this heating up and cooling down anymore. So there are really value you can show and present to the customer with this kind of technology.
Yeah, I think also it must be bigger, as when you see the normal cycle time, 2/3 of the cycle time is cooling the metal and spraying, and the rest is all the other things like opening, closing, taking the parts out. And if you have a better cooling, your metal solidifies quicker, and also when your spray time is reduced because you don't need to cool the tool, there's so much saving in just changing out the release agent with the consequences behind it. And for me, the big question always in the foundries is, why isn't everybody doing it? Or is it just that small increase of costs at the beginning is a no-go for such purchasing organizations?
This is really a good question. I think the first answer is, it is quite difficult to get figures, to get facts. Even we have today a lot of possibilities to measure whatever. It is quite hard to install it in a running production. Either there are no connections that you can get in, or sometimes it means you are stopping production for quite a while to install something. And production in a high-pressure die casting foundry, it should run. This is what the foundry is making money. So the other thing is, philosophy of the companies, that they think they might not need so much money. And I think it's a natural tending of human being. I believe. And really to make progress, you should rely on facts, because they are black or white and you can orientate on them. Of course, you have an initial higher invest to start all the technology. But I like this comparison. I have seen someone sketch, and there were two guys. They had a lorry. One was pulling and the other was pushing. The lorry had wheels from stone, and there was everything then perfect. The load of them was nice tires from rubber, round and smooth. And then the pushing guy said, hey, it's so demanding. I'm exhausted. Can't we make a stop? And maybe we could change the tires. And the pulling guy was saying, no, we don't have time to make a break because we are under time pressure. Continue to pushing and let's finalize this task. And I think this is a good example that you are faced with this kind of situation very often. And I think if we are open to ourselves, it happens also in our life, private and in business life. We are so under pressure, time pressure. We know that we need to make changes, but we simply don't find the time and the energy to make this change.
Until vacation. Haven't you seen when you go on vacation how many people that are actually jogging at the hotel? If you go to Mallorca, everybody's jogging the first morning. The second morning is half of them, and the third morning is a quarter of them, and then no one jogs anymore. As soon as we have a vacation, then we have time to think. I'm going to rebuild myself. Yeah. I'm interested in one thing that no one can answer in this room, and that is actually the hidden cost around this. I mean, if I look at the list of things that you proposed here, which I have seen myself is working, I wonder how much you save on not needing to discuss the second tool with your customer, corrosion problems in tooling being worn too quick, all the water, all the filth, I mean, the smoke filters. There's a second layer on the onion here. I mean, now we had the hard facts. We have the fresh water. We have the cycle time. We know that the tool life length will be prolonged, maybe 25% something. We know HERA is the shit for this, the center core. But imagine if in a few years when we can see the second layer here. I mean, less business risk. I mean, only that is a value by having a new tool.
Just add to that. Which controller has in its calculation, okay, we have a tool lifetime of calculated 100,000 shots, but I know because we save a bit of money at the beginning that we need at least 2 people per shift after 30,000 shots to grind off the heat cracks. And then after 60,000, we have 3 people. Who's going to plan for that? Now these costs come up, add up, and that's basically your margin is gone.
Yeah, that's why I'm interested in the margin. I mean, if you look at a business cycle, the typical casting foundry has what, 3% units in average. End of the day, they have some good years, some bad years, and some average years. Imagine if you say 3% units going direct to the final line of profit, you got 6 instead of 3. And then it's a family business. You have been running it from 1976. I mean, imagine the money that is actually piling up here.
Yeah, can be quite hard. I'm fully with you, gentlemen. So you brought all the points on. These are the soft facts, which are not considered very often. They are known, but they are not tracked properly.
How do you start an efficiency journey? I mean, let's face it. Many of our listeners are hardworking guys that are seeking information. Some of them have taken over a foundry maybe from the dad or uncle or I don't know, grandma. And they're looking into the production, they see the smoke plumes. They're doing a good job. They're working hard. But if they want to start this development journey with Chem-Trend, how do they do?
We need to fix in the beginning, what is the consumption? What is the cycle time? How much do we need release agent per shot? If you go for efficiency improvements with the release agent. Once this is known, then the question is how we can improve the process itself. For instance, if we go for another release agent, can we reduce the application time, the spray time? So this is already something what lifts the productivity in a foundry. The other thing is, of course, the scrap rate. All the things we try to write down, to assess them, and find out where are the areas we can bring first the low-hanging fruits, the easy improvements. Because if an improvement is too difficult, too demanding, then you can be quite sure the team has not the power to push it through. But it's important to find the low-hanging fruits, and we try to find them together with the customer, and then we present it and make an offer how we can improve the process. It sounds quite easy, but in nature, it's much more harder. You have sometimes also personal restrictions which do not allow improvements. So you have all kind of obstacles which you have in normal life.
But you know how to tackle them. I mean, you do this for a living since, what is it, 27 years?
Correct, yeah.
Correct, yeah. I mean, it comes with the territory to...
You learn every day if you are willing.
Yeah, you do. You actually do. So, getting into another question here. Where do you think the die casting industry is heading?
This is a good question. Stefan, if I would know this, believe me, I would also tip the right figures for Lotto at the weekend.
Yeah, but this is a guessing game. I mean, you spend also your working day in our dairy industry, so you probably have a good gut feel.
Honestly feeling, I think the industry I think they have realized that we are in challenging times. But it will be definitely more demanding parts because those parts are the base we can differentiate from other areas on this globe. Everything what is easy to make with no big investments, this will disappear somewhere to low-cost countries. Mm-hmm. So means then more difficult the parts become, then more it will be something which will remain in Europe. And then, of course, there will be different approaches to it. Some are starting with gigacasting and making really huge parts, casting the rear bodies of a car. Others can't go into this kind of technology because if they have an existing infrastructure, it is almost impossible to install a gigacasting machine of 8,000-9,000 tons. It's not the machine itself, it's also the whole infrastructure, what you need to consider for such kind of process. On the other side, there are also a lot of technologies which grew up over the years, like welding of parts, bonding of parts. So means if you have already some big machines up to 3,000-4,000 tons, 5,000 tons, maybe you will be able to produce on two machines and then somehow combine the parts. So there are several possibilities how to sustain in Europe in the die casting industry. Oh. And I think the most important is that we get still more efficiency in energy consumption because energy did rise all over Europe. There may be some differences between the countries, that some countries has extremely high electricity prices, some lower. And then for the high price countries, it looks, they have no issues. But also the lower cost countries for energy, they are suffering because for their level of calculations, the energy prices are still above 30-40% before all this mess started. Mm. So I think some consolidation will happen and the trend will go definitely to more complex parts which will be produced in Europe, and this on either very big machines or gigacasting machines.
Interesting. So to sum it up, basically to keep European foundries alive, they have to face two directions. One, increase the efficiency, and the other thing is increase the technology level so that the castings they produce are way more complex, that they're building a moat because of the complexity.
Correct. They have to deepen the value chain, what they are doing with the parts, and they have to supply more components to the tier 1 or OEMs than just cast parts.
I would like to add here. So basically, like, they also have to do a bit of business development, not just download it from the portal, the part, offer it on more or less, go to the tier 1, to the OEM, say, hey, what is surrounding that part? Can we offer you a more holistic solution that captures more and then get a unique solution? Is that something that you also would recommend?
I fully agree with your assessment, Fabian. I think this will be the way. We have already some foundries in the market who are going this way, or that start to go this way. And I think as soon as you go to a deeper added value process, you have more flexibility and higher profitability. For instance, if you're machining the parts and assembling them in-house as a component, if you have some quality issues at the part and you do the in-house machining and assembling of the parts, you detect much sooner such kind of defects, which are always paired with production, than if you send them out maybe to a toy manufacturer, he is forwarding them further, and then the parts land somewhere at tier 1 or OEM, and they detect, oops, there is a quality issue, and then you get the big claim to solve it.
Usually when that thing happens, that's the worst thing, because there were some smaller defects where nobody cared about, everything worked well, but as soon as one big thing pops up, everything is at questions, and then you have to solve issues that you weren't able to solve 2 years past. And that will be a hell of a claim then, to solve that in a short amount of time with a thin layer of extra hands.
Fully correct, Fabian.
I've been a supplier to the tier 1 industry of millions and millions of parts. I can sign that document and that statement.
Yeah, we have talked about this, Stefan, when I was at your location.
Yeah, but I don't think we should quote what we just said and discuss that back then. But
no. Leave the history.
We leave the history. Speaking about history, if you would meet young Darko, being 20, thinking about starting in the die casting industry, what kind of advice, career advice, would you give to young Darko?
The foundry industry is still a very interesting industry. And I think that we need to consider today, it is not as dirty as it was in the past anymore. So the jobs in a foundry, they are on a much higher level today. There are a lot of technologists which are needed to make all these complex and demanding parts. So to me, the foundry industry is still something what is a very interesting and challenging industry. It doesn't need to be the law degrees or maybe some medical degrees only. So I would suggest the young Darko, feel free, go into a foundry. There are a lot of possibilities and challenges. You will like them. And I think important to young Darko is have an information exchange. Don't believe because you have studied or you are well educated, you know everything already. Make an interaction with the older colleagues. Ask them, exchange informations with them, because you can really benefit of the knowledge of older colleagues.
Well, that's a great point. I think that comes short in so many foundries, that the knowledge transfer, even if people leaving or people go into retirement, that information goes with them. It's not continued on to a wide spread of people.
This is correct, Fabian. Yeah, it's a hard cut, and then the knowledge is gone.
Very wise words to young Darko in his career there, and kind of left me speechless. Being 54, when you say that you should listen to the experience of all the guys, makes me a little bit warm. I don't know about you, Fabian. You're still the youngster in this team. Dear Darko, it has been a pleasure. We've been talking now for almost an hour, and I know you since before. I know that we will shake hands many times at Eurogases and shop floors around Europe and the world, and definitely looking forward to it. And I imagine that HERA is not the last development that we'll see from Chem-Trend either. So thank you very much for being in the pod, and for you guys that are thinking about this development journey, pick up the phone. Call Darko. If you don't find Darko, call me and I will chase Darko for you. So thank you, Darko.
Thank you, Stefan, for this very nice words. And Stefan, Fabian, thank you very much for your invitation to the session. It was a pleasure and great to talk to you. Nice atmosphere. And I'm sure we will shake hands soon somewhere on a shop floor, and latest at the Eurogos 2026.
You know it.
That's perfect. Yeah, thank you for being it. Do you have any last words, especially one specific use cases where you want foundries definitely to give you a call?
Oh, there are some, but I don't want to mention them now by name. So
No, not the company. So more like the use cases or the applications where they, okay, that's the perfect application where we can have a major impact on your business.
certainly, we can support the industry with some new approved release agents from the OEMs. We have various approvals gained over the last 2 years, and whatever OEM is supported by the foundry industry, feel free to call us, to ask us. We have the solutions for them.
That's great.
That's perfect. And then, yeah, contact Darko. And when you're still listening at that time, push the like button and the subscribe button that you don't miss the next episode. And then, thank you for listening. See you next time. Bye.
Bye-bye.
Thank you for listening.
Sayonara.
Yeah. Bye-bye.